the TimeWise library can integrate with different programming languages. So this app is written in Python, and this app calls the TimeWise library, and we can process data using this app. Let's run this app. We can load the data file here. So this is the S2P data file. It is copied from the VNA to this laptop. And the measurement data, this measurement data is a pair of 3181 mini biconical antennas. So the S2P file has S11, S21, S12, S22. We can choose them here. And now we choose S21. The top figure is a time domain view of the antenna response. The bottom figure shows the frequency domain view of the antenna response. Let's choose the starting time and the ending time of the time domain view. So the main peak happens at 6.12 nanosecond. If we want to apply a bandpass gate on the main time impulse, we can choose the gate starting time as 4.12 and gate stop time at 8.12. We can choose the gate shape here, bandpass gate or notch gate here, and edge treatment technique here. Okay, let's just choose normal gate shape, bandpass gate, and renorm edge treatment. Okay, so this orange curve is the gated data in time domain, and this orange curve is gated data in frequency domain. So now we apply a bandpass gate to only include antenna to antenna response, so we can get this clean and smooth curve in frequency domain. We can also zoom in and put a cursor here. So this is the biggest reflection in the time domain view. So let's apply a notch gate to notch this out. So the biggest reflection happens at 9.03 nanosecond. So let's set the gate starting at 8.03 and at 10.03. We can still use this norm shape, and let's choose notch, apply. Okay, so now we notch out this biggest reflection in time domain view. So then we get this orange curve in frequency domain. So it shows by notching this out, we can remove some of the ripples on the frequency domain curve.